Thank you, Thomas. Good morning. I'm Albertus. So today I'm going to talk about my PhD project, which is on automated assessment and improvement of web scraper configurations. So web scraping is a way to automatically extract information from web pages into a structured format, usually done in a batch way per website. And yeah, typically the scrapers are constructed manually per website. So for example, if I want to scrape from this IMDb movie website, I would have to come up with the XPath configurations for each of the attribute that I'm interested in. So for example, the title and the genre. And then in an ideal case, because a website typically consists of web pages that are constructed in the same way, so they have similar HTML templates, similar structure. So in an ideal case, this XPath would work for all of the web pages from the same websites. But they certainly would not work for other websites. So it is quite tedious or very tedious if I want to do this exercise over and over again for all of the websites that I'm interested in, especially when you're trying to scrape from a lot of websites. So recently there have been some work that tries to use LLMs to automate these web scraper constructions. So in general, they work like this. You give a couple of web pages from the target website that you're interested in into the LLM, and then the LLM will output the XPath configurations for the attribute, for example, like the title or the genre. And then we just use that generated XPath to the rest of the web pages from the same website. And then we finally get the extracted values from all web pages from that website. But as with any work that use LLMs, there is this question on whether the outputs are always reliable. And of course, the answer is not really, not always. So in this example, we want to get the XPath for the job title, for example. So we ask the LLM to generate the XPath, and then it outputs this XPath that looks valid, a valid XPath. But then when we try to use it to actually scrape from the web page here, in addition to the correct job title, the QA manager here, it also extracts some irrelevant values, such as this job seeker login, new users, news and events. This is because they are under the same H3 element, which is specified in the XPath that were generated there. So it means that this XPath is not specific enough for the value that we're interested in. Other issues include often the XPaths are not generalizable to the whole website, so it works for some of the web pages, but not for all of the web pages from the same website. And sometimes the XPath is just straight up hallucinations. So there is a need to be able to assess whether the generated XPath is actually correct or not in an unsupervised way, especially in the realistic scenario where during construction of these scrapers, we don't have access to the ground truth. So I come up with this scaffold scraping configuration assessment framework, whose aim is to try to assess the generated XPaths and then try to improve them if they were detected as incorrect in the assessment. So the box on the left here is what we've seen before, which is the generation module, where we generate the initial XPath, and then the two boxes in the middle are the assessment modules, consisting of two types of approaches, the embedding-based assessment and LLM-based assessment. And finally, we have the regeneration module here on the right, where it tries to improve or fix the XPath that were detected as potentially incorrect from the previous step through regeneration to the LLM again. So the embedding-based assessment, the intuition is that for the same attribute, correct extracted values should be semantically similar across different websites. This means that, for example, if I was extracting the general values from the IMDb movie websites earlier, then if they are correct, then the general values should be semantic similar in the embedding space with other general values from other websites. So we use embedding similarities for this. We encode the extracted values using sentence encoders. If we have some reliable values that we can use as references, we can even fine-tune the sentence encoders. I experimented with various similarity metrics to compare the embeddings and come up with some of my own, including the hierarchical silhouette scores here. So we've used LLM to generate the configurations, the XPaths. So why not use LLMs again to actually assess the generated XPaths? So I experimented with this LLM as a judge approach, where the LLM is asked to judge whether the extracted values actually match the intended attribute or not. But as with any work with LLM prompting, there's a lot of variations on how you can construct the prompts. So I only focus on these variations, including the output formats, whether the LM should output just true or false or with a score, and whether the LM should also output the reason on why it thinks the exact values are incorrect or not, and these other dimensions. So there's a lot of results, but I'm just going to show you some of the important ones. So these are the F1 scores of the assessment module, so detecting whether the XPaths are correct or incorrect. So the LLMs at the top there, Gemini 1.1 Flash, GPT-4 Mini, DeepSeek, V3 are the ones that were used to generate the initial configuration. The top two methods there are some representative of the embedding-based methods. The rest are some of the LLM-based methods with the prompt settings optimized on the validation set. So from here, we can see that actually the performance of the embedding-based methods are on par with the LLM-based method, 73, 74 on average, compared to the highest of the LLM-based method, 76. But actually within the LLM-based methods themselves, there are quite some variations depending on the specific prompt settings that were used. And now for the regeneration. So once we have already the potentially incorrect XPaths detected on the previous step, on the assessment step, now we can try to improve them through this regeneration. So this time, not only sending the seed web pages to the LLM, we also send the incorrect XPath and then the previously extracted values that were incorrect. And as an option, we can also include the incorrectness reason if generated. And from the results here, so the blue bars here are the performance of the original XPaths. You can see here that they're quite low. But then once we regenerate them through to the embedding base or the LLM base, which is the yellow and the red ones, the performance improve. But you can see here that the performance of the embedding base and LLM are quite similar. But once we include the incorrectness reason, which is the green bar here, then it improves again slightly. So I guess to conclude, what I want to say is that the regeneration after targeted assessment does improve the quality of extractions. But there is a ceiling at some point where even with the Oracle assessment, where you only send for regeneration all of the XPaths that were known to be incorrect, there is still a huge gap to get a perfect performance. So I think for the future, actually, if we want to produce a more reliable XPath, the key is on the LLM to produce them, and maybe one way to do that is to fine-tune the LLM specifically for this XPath generation task. So that's all I have to say for now. Thank you.
Yeah, thanks a lot. We have a question here.
Thank you for your talk. My question is just particularly on this slide. It appears you used small LLM models. Any reason why you stuck to that? And if you had used larger ones like some of the latest and best, would there be any difference in your results?
Yeah, good point. So, I mean, yeah, if we look at this, the three LLMs. So actually, the first two are the smaller models, and the DeepSeek is the largest. Is the best model here. So actually, when we look at the results here, which is the red one, which is the big model DeepSeek, there is still quite sorry. You're looking at this here. So DeepSeek here, you can see here, it's still quite low, the performance, even though it's high, it's a bigger model compared to the GPT-4 and Gemini 1.1 Flash. But yeah.
Yeah, just a follow-up question on that is, if you had used, for example, GPT-5 or the latest one you have now, would there be need for a regeneration? Because from what you said, it appears that the essence for the regeneration is because there might be some irrelevant, sorry, forgive me, I'm not an expert in this, but do you expect that there would be no need for the regeneration if you had used a more capable LLM? That's my question.
Yeah, I think yeah, that's something that we need to experiment. I haven't tried the latest models yet. Certainly, we would hope so that the performance would improve, but there's still the question if the performance is not perfect, maybe there is another way to try to improve them through fine tuning of DLM specifically for the task for this task. But yeah, certainly bigger model would probably help with this.
I was actually going to say the opposite. This seems like the kind of mechanistic task that LLMs should be very good at, but clearly they're not. So would you say that with have you done any sort of preliminary experiments with fine tuning?
No.
Okay. Because I would say you could maybe use a much smaller model because it's a very specific domain, right? Your input is all HTML, your output is DSL, as I understand it. Like I feel a reasoning model seems like huge overkill for this.
Yeah, good point. I mean, I think it's one of those two. Like if you try to use the bigger models, which like maybe somehow already knows about this task, or we can fine tune a smaller model specifically for this task. So yeah.
Okay, yeah, thank you.